Welcome to the bi-weekly webinar we host at Dashbird. Really glad that you're all here. My name is Saver Ahmed. I will be your host today, and I will do a chat and kind of a presentation later as well. With me joining today is Tim Robinson from AWS and Pobia from AWS. They will be doing a deep dive into observability and microservice tracing with AWS Xray. Looking forward to hearing the talk as well. After which, I will do a presentation about serverless observability and how we approach it at Dashbird and what we see our customers facing and kind of how to be the best at monitoring. During this whole webinar, you're free to ask questions in the YouTube chat. All of those questions will be answered right after each one of the talks that we're giving. And out of all the people that are asking questions, we will also send some Dashbird merch to some of the lucky ones that we choose from the audience. Hope you enjoy this webinar, and yeah, feel free to leave any feedback, comments, ideas for next time. And yeah, let's go. So hand it over to you, Tim.
Thanks very much, Tavi. So hello to everyone. My name's Tim Robinson. I work for the Well-Architected Geo Solutions team, and I run the Solution Architect function for APAC. Bob, do you want to just say a quick hello and introduce yourself?
Bob, yeah, I'm also the Geo Solution Architect, the same team with Tim.
Good stuff. So we're going to talk about microservices and really customer movement from traditional monolith architecture into microservices, and then really give you an introduction to Xray and how that plays in the observability space. So let's get going. So within Well-Architected, we really strive to achieve awareness of best practice with all of our AWS customers. And one of the functions that we use to do that is our review process. And really our review process, which we run with customers, seeks to disseminate that best practice advice through the use of interactive sessions with customers. So we run that review process across distinct architectural pillars. I'm going to take you through those pillars and give you a quick introduction now, and then we'll deep dive on today's subject. So really, AWS sees architecture as 5 distinct vertical pillars. So from the left, we've got operational excellence, or a customer's capability to be able to operate their workload on a day-to-day basis. Security, and really evaluation of a customer's capability to run their workload securely within the cloud, and to have security present at multiple layers within the workload. Reliability, and the customer's ability to be able to continue the operation of their workload regardless of external factors, perhaps the degradation or failure of a hardware component. Anything like that is really covered under the reliability pillar. We then move to performance efficiency, and really maintaining performance regardless of external factors like perhaps an influx of customers or something of that nature. And then really into cost optimization. So really working with customers to ensure that their workloads that run in the cloud are run at the most cost optimized manner. So through this review process and through asking questions appropriate to each of these pillars, we're really able to work with each of our customers to determine the areas where their workloads can improve, perhaps over an immediate period, and really suggest areas, perhaps services that they can benefit from, that they can roadmap into the future of their product. So today's session is really focused on the performance efficiency pillar. So really, as I mentioned previously, what do we really mean by performance efficiency? And what we're really focused on doing is efficiently using those computing resources to maintain, regardless of demand changes external to that workload, and also to be able to absorb technologies as they evolve and to really factor those in. So making sure that we've got adequate performance coming into those workloads, and we can maintain that performance efficiency regardless of external factors. So inside each pillar, we have a number of design principles, and through working to understand with customers if those design principles are being met, we can really understand areas that they can work to improve and focus on, and really give them suggestions for improvement for the immediate future. So when we look at design principles for performance, we really look at these categories. So firstly, the ability for a customer to democratize advanced technologies. So if we look at traditional architecture, if a customer wanted to take advantage of new technologies, perhaps machine learning or analytics or something like that, that would traditionally involve recruitment of those specialist skills. Through the use of advanced AWS services and also managed services that we integrate into architecture, a customer can really democratize those advanced technologies and really get output from that with minimal effort and without the need to invest in those specialist resources. We also talk to customers about going global in minutes, or being able to templatize infrastructure in order to recreate it. So as their business grows, perhaps they acquire a customer base outside of their primary geo. They can use that templatization to spin up new instances of their application in minutes. Next is the use of serverless architectures, and again talking to customers about how serverless architectures can complement perhaps the design of their existing architecture, and then really working to make sure that that serverless architecture is levied in the best possible way to perhaps achieve cost reduction or to perhaps improve efficiency. Next, we come on to experimentation, and again, experimentation in the cloud is incredibly easy compared to what we were used to working with on-premise infrastructure. Being able to levy services and to spin services up very quickly, test them out, and to potentially develop and build out new lines of businesses means that customers can experiment a lot more often with new services, try them out very quickly, and then see what effect it has on their business. And finally, mechanical sympathy, which is really working with customers to educate them to use the right tool for the right job, and to ensure that when they're using services, they're really using them in the correct manner for which they're intended. So today's session is going to be focused on the use of serverless architectures, really deep diving into how we effectively levy those architectures, and really how we work to cope with the increased complexity that sometimes comes with the use of serverless. Now, most customers that have moved to cloud have cited that really one of the reasons that speeds up their movement to cloud is really that they need to rework a lot of their existing applications from monolith design to microservice. A lot of customers talk to us about the benefits of microservice and of using this mesh design over the traditional monolith approach. So what we want to do today is to look at that monolith approach and how a traditional software was architected, look at microservices and how that contrasts, and then talk about the relative benefits and the associated complexities that comes with the movement into that design. So we're going to start with monolith now. So I'm going to kind of bring Bob in to kind of complement the conversation. So Bob, do you want to take us through monolith design and really what that represents as a software approach?
Yeah, thank you, Tim. So I would say the monolith is a traditional way of the software development approach. Usually, you will need a big team to work together to build these software applications, and usually it will create a huge size of the code base. And since you got a lot of people working together, then the internal operations, since they sometimes have a lot of dependency. My code depend on your design, and your design depend on John's creates libraries. So it kind of create a lot of overhead inside the communication. So as a result, the internal complexity grows, and the iteration pace will kind of be more slower than compared with today the microservices style. And in this case, for example, the traditional enterprise software that might only capable to do the release maybe by quarterly or the 2 months at a time. So I would say that's not that efficient enough.
Okay, so kind of to summarize, we're really looking at a software approach where we've got very large teams. These teams kind of work together on this highly complex single design. Again, that design's got a lot of internal dependencies, and because of that quite large complexity and that quite large piece of code that's got to be iterated on as a joint exercise, we're really looking at quite an extended iteration cycle. So I'm going to cut across now to really what microservices represent. So Bob, how does that kind of contrast to our monolith model that we just looked at?
Well, yeah, it just reminds me to compare with these two different styles. The monolith usually it will have a multiple purpose in one big design, one big Titan bundle application. But in the microservices, we can divide those. There's a different purpose. Each of the one purpose it can set. Device split into one small service, and then you can decouple your huge size application into a lot of small service. Then each of these services they can communicate with each other. So I would say as a small size of the service, it can also be managed and maintained by a separate developer or small group teams. Then they can operate parallelly, separate with each other independently. Then they will remove a lot of the internal independency.
Yeah. So, I mean, this is very much a contrasting model, right? So we're moving away from everything really under one roof to the creation of small pieces, those small pieces being very specific in nature. And really each service being managed by perhaps a small pizza team, and really it's not always a one-to-one relationship. So sometimes you'll have a developer that will work
maybe
on,
like a one small group. They can they might maybe handle more 2 or 3 functions in one small team, but each of those functions they can iterate by separately in parallel.
Right. So, I mean, like, this has obviously got quite a lot of benefits for us, right? Because we've now got these small teams that are working kind of in parallel on these individual services. So, like, the result's going to be like a massive uptick in iteration as we kind of adopt this model. And again, each of these individual services, you talked about the kind of the communication between them. So we rather than having internal function calls, we've now got kind of externalized communication. But really, the iteration cycles massively increased by the adoption of this alternative method. So we can really iterate our service in a lot more efficient manner, and really break that complexity into individual components. I'm going to move across to this slide now. So really, again, this kind of enforces what we were saying previously, but again, we're bringing in some new concepts here. So, you can see from the diagram here that we've got the co-join of multiple different programming languages. And again, this is really one of the key components of microservices. So because we've moved away from this single monolith design, what we can do now is take those individual services and they can be coded in a variety of languages. So again, like, you may be working with development teams that have a particular familiarity with a language, or maybe you're trying to solve a problem that a particular language lends itself towards. And in all of these cases, it may be appropriate to perhaps work with 2 or 3 different programming languages. It may be appropriate to code everything in a single language. But again, this gives you the flexibility to be able to adjust your approach accordingly, according to the problem you're trying to solve, or according to the skill set of the people that you're working with. And again, keeping on that theme of flexibility, when we talk about this service mesh and this externalized communication, it really gives us a lot of flexibility in terms of the technology that we're working with. So we're not really restricting this just to perhaps serverless technology like Lambda in the cloud. We can really levy things like containers, we can levy managed services, even virtual machines or on-premise technology, and all of this can really be built into this service mesh due to this externalized communication. So again, even more flexibility in this approach. So again, Bob, like we've talked so far today about like the benefits of microservices, and it really seems like a straightforward decision that organizations need to take. You know, we talked about the parallelization of work effort, the flexibility of using different languages, and it really seems like a superior approach. But we kind of have some increased complexity that comes into play. So like what do customers some kind of experience in terms of complexity in moving to serverless? And then perhaps we'll kind of talk to the audience about observability as a concept. So let's start with some of the factors that a customer would experience when they're moving towards serverless. So, as Bob's mentioned previously, the communication of these microservices is externalized. So that really lends us to kind of a fresh problem in certain cases. So we're now dependent on external factors, be it a network or something of that nature. But because this communication is externalized, it now becomes really vital that we're able to closely monitor that communication, and where that mesh becomes degraded or we see a lack of operational health, that we're able to kind of interject, and if we find issues, that we're able to remediate them quickly. So again, not really necessarily a problem, but making sure that we can understand that communication across that service mesh between those different services means that our microservice mesh remains healthy and we can intervene at a particular point where we need to. And this kind of brings us on to observability. So what do we really mean by observability? Really, it's everything that I've just described. So the capability of perhaps an operations team or a development team to be able to view that service mesh effectively, to be able to understand what represents a degraded service state, and then to be able to intervene before they reach that point of perhaps latency or something like that, where we experience an outage. So again, really looking at this slide, this really illustrates exactly what I've been talking about. So again, we can see as time goes on, we've got a fairly average style of latency. Then we drop into a degraded state. Now, if this goes unattended, that degraded state can continue. Perhaps we experience even more latency, and then we drop to a point where we may experience an outage within a certain section of that service mesh. So what does that represent to a customer? It could really represent anything, but suffice to say that that might stop that application from functioning correctly. It might stop that application from returning data. So we want to be able to intervene before we get to that point. So from an AWS perspective, we have a service, and that service is Xray, and that allows us to kind of view our services as a mesh and to really be able to work to debug issues before they reach that vital point of creating an outage. So, Bob, do you want to kind of talk us through this service map view and what we're seeing here?
Tim, can you hear me? Okay, good. Yeah, the AWS Xray is a managed service, help us to monitor the Lambda and those serverless architecture more easy. On the diagram, you can see a different small circle, and that each of those represent to one single service. And what I mean in one single service, it could be a Lambda function, or it could be the other AWS managed service, or some service you defined it. So, and there is a different color on the circle. The green means the this service run as you expect, and the red means okay, it was not running correctly, and the yellow means it run but it returns some error code. So for example, I will give a quick demo later. It will have an integration with some AWS managed service. We call it as Amazon Translate. Then if we input some languages that not yet supported by the translate, it will return the 400s. That means that language does not support. So this running code will cannot be processed.
Cool. Okay. I just want to kind of recap for the audience. So really, like, each one of these circles represents an individual service within the mesh. So we've got that colored border there. So what does the colored border represent? So when we talk about intercommunication between that service mesh, we're normally talking about like return codes. So or HTTP return codes. So where we've got a green color here, that's normally a 200 code. You can see in some of the circles here, we've got like red. So red is normally indicative of a server fault. So that would be like a 500 series error. And where we got yellow, so you can see a couple here. You can see one quite predominant in the bottom right-hand side, which is DynamoDB. That's a yellow. So that kind of indicates a 400 error or a client error. And we haven't got an example in the picture here, but you can also indicate purple, which is indicative of a throttling error. So that's kind of like a 429 error. I think it's 429 error, which is like too many requests. So let's kind of continue. So like we've shown the service map. So this is really a trace view. So what's kind of going on here, Bob?
So on this diagram, we can see the left side is tell the user which of the procedural part you are running through, and the right hand side you can see there was a chart that indicate the running time, the running durations, and it also represents each sub-segment of the process logic. And in the middle, you can see there's one small red point there. Okay. Yep. So audience, you can zoom in the screen. You can see there was a 400, which means the procedure inside there was some error there.
Yeah. So again, like we're tracing we're tracing a request coming into our application, and again we can see from top to bottom here. So we've got that request coming in through Elastic Beanstalk, and then we got it drifted into DynamoDB, and then a number of different interactions there, and then we can kind of see like those 200 codes turning into that 400, and that's where we get that status alert generated there. So if we're in a debug cycle, then maybe that's really a good place for us to start and look.
Yeah, definitely.
So again, like we move on to segments. So perhaps kind of explain to the audience what's going on here, Bob.
Okay. In some cases, we want to do maybe the profiling, the performance profiling, and then this diagram shows a perfect case. If we see the whole table, it contains a lot of DynamoDB assets, and then by the logic, it will the logic wins step by step. It query the data by sequence. So we want to see, okay, which of the whole logic might be taking the longest time within the whole process. So I think to monitor the healthiness of the procedure or to measure the performance, this is a very good approach to use.
Awesome, thank you. Okay, so when we talk about Xray and integrating our code with Xray, there's a number of kind of steps that we need to go through. So we need to kind of tell the code that Xray exists, but we're obviously talking to more than just code. We've got a number of other areas that we need to kind of configure. So do you just want to kind of talk us through, Bob, what needs to be done in terms of enabling Xray tracing?
Well, I would say that was not that complex. So we only need to we only need to enable two settings to enable the traceability in the Lambda and also in the API gateway things. And there's one more step we need to approach is to inject one line. I would say only one line into the code. That's the audience can see in my later demo. Maybe you can see the
I've even got a slide on it, Bob. Hang on. Right, let's go to the next slide. So I'll just go back to this one and just kind of make sure that people kind of understand. So we need to do enabling from the console, from the AWS console perspective here. So just that tick box. And then again, because we're talking about external requests, we need to make sure that the API gateway is aware. So just enabling the tracing from the gateway perspective. And again, like as Bob mentioned, you need to kind of make your code aware that you want to include Xray tracing. So again, as Bob mentioned, like just including those lines to reference the Xray SDK and then to call that capture that capture function below. And then again, your code will start and stream information through to Xray itself. So I think we've probably talked enough for now, Bob. So, like, do you want to just give the audience a quick demo?
Sure. Let me share
perhaps take them through a real world example.
Yeah. Let me share my desktop. So, Tavi, please help to share my desktop. So, Tim, can you see my desktop?
Are you there, Tavi? Is Bob sharing his desktop?
Yeah.
Okay.
Good stuff.
Cool. Okay.
Go on, Bob. Off you
go. When Tim was just presenting, so at the same time I was playing with the whole stack I prepared for this demonstration. So we have a simple API gateway and the Lambda applications. And there was an endpoint. So audience, please do not play with this the endpoint at the same time, because it might fire up some highly concurrent Fortune 9 error. But you can see I design a different kind of input. It will usually it will return the different response. For example, you can see there was 502-bit gateway design, and it can respond what we designed. So after this process, we can refresh the AWS gateway. There was one feature here, the service map. You can see this service map explain what exactly is in the whole process. So let me zoom in here. Okay, at the first beginning, all the requests will walk through the API gateway and then going into the Lambda context, then call the Lambda functions. In this Lambda function, it integrates with the translate and comprehend, then also the DynamoDB, which these architecture give us a quick demo about the microservice, because in the monolith design we have to bundle all these in one big code base, but now you can leverage the remote procedure code.
We've now got that,
that
service mesh. So just so the audience are aware, so this demo application, this allows us to send. I think the demo application we can kind of send greetings in multiple languages, and then we use a mix of comprehend. We got a database in the back end of the code, and then that if your message is present in that database, then you get an appropriate response.
Okay, and at the same time, there was one more feature I want all the audience to see is the trace. So if we go into the trace tab in the Xray console, you can see a lot of different detail here. So at the bottom of the page, you can see there is a trace list. You can see there was several requests coming in. I said that's the last 5 minutes. So you can see the request ID and when was it happened, 4.6 minutes ago, and the response status here. So what give us a clue to do the debug is, okay, this is 502. Then we click into that to see is there any detail. So can see here the whole request was not run as our expect, so we can jump into that to see. The translate, this is 400, and there was some detail. It will tell us what really happened in the exception things, and there was also the raw data tell us what really happened. So at the bottom it shows unsupported languages. So that's a good example for us to leverage the tracing to do the debug.
Awesome. Thanks a lot for that, Bob. It's really good. Okay, Tavi, shall we cut back to my deck and I'll just wrap up and then we can thank you.
Awesome. I think it's
so I think I've only got one more slide. So I just put some resources together for today's session. So again, just a resource list of stuff that we talked about today. So for those of you that want to have a play with Xray, and please do, it's a really awesome service. So and we really love we really love doing talks on it, really talking about observability and again how that plays back into well architected. So please go and take a look at our demo software. And you can download it and play happily, and kind of it's got all of the integration with Xray built in. For those of you that are keen on getting some hands-on exposure in terms of best practice, we've got a number of patterns available on our Well-Architected Labs website. So we built a number of interactive labs that cover all of the pillars that I talked about. So please go and check those out. They're really good learning resources. And again, if you're studying for exams or you want to think about integration and working deeper with one of our pillars, or you want to improve your security posture, it's a really great way to get started and to really see what's available in terms of kind of hands-on learning. We've got a landing page here for Well Architected, and that will point you in the direction of a lot of the resources and documentation that we use on a daily basis, and that we use to kind of work with customers to talk to them about best practice. There's the Well Architected tool in the console. Again, we use the Well Architected tool when we run through reviews with customers, and it's also a mine of information on really how to structure a review. Again, if you want to run a review, I can't even speak now. If you want to run a review yourself on your architecture, it's definitely recommended. And again, the outcome should point you in the direction of areas where you can really work to improve your offering. And finally, the solutions page. So we've got vetted solutions that are built with best practice design in mind. And again, you can use these for educational purposes or really to give you a head start if you're thinking of looking at new areas of architecture. So again, please check out that solution page. I kind of talked enough now, so I'm going to pass back to Tavi. So thanks very much for having us, Tavi, and back to you.
Awesome. Actually, thank you so much, Tim. This was a great talk, and Bob as well. We do have one question in the meantime. So the question goes as follows. In practical use cases, would you suggest teams to use multiple runtimes to build, or like programming languages to build microservices in serverless? Think of a scenario when there's a team that is really used to Python and like another team is using Node.js. What's your understanding of feeling about that?
I mean, like I think it really goes according to use case. Is the only advice I can give. So personally, when we code ourselves, I like to use one language, and I've got my language of choice, and I really don't want to get into a debate on what's the best language or anything like that. But I've got the language that I'm comfortable with, and I'm proficient in, and I can do the most in that. So that's kind of what I choose. If you've got a particular problem that you're trying to solve, and it's maybe very maths heavy, or there's particular libraries that you need to include, then you've got the option of using that through that particular language. So again, a lot of the answer is dependent on the problem that you're trying to solve. I think for simplicity basis, and if you're working with a small team of people, probably coding in one language is advisable. But again, if you've got a dispersed team, and like there's multiple solutions that you can code with serverless. You can code anything from like a very small application all the way up to a dispersed architecture. Like Netflix springs to mind, or anything of that nature, where you've got literally hundreds, maybe thousands of these services all talking to each other in a gigantic mesh. In that case, like, it probably lends itself to multiple technologies and multiple languages. So I think probably in summary, there's no real right or wrong way to do it. We just kind of offer the flexibility for you to be able to really choose your own path.
Awesome. Yeah, I completely agree. I think like from our previous experience building Dashbird, or even before that, we've used multiple languages, depending on the need and kind of the use case. And awesome. So thank you so much, Tim and Paul.
Most welcome.
Really enjoyed. Actually, there's one more question that just came up. I think that is related to the last question. Is there any set rule you use to configure sampling value, or would it be based on the type of microservice? I think this goes for Xray and like configuring sampling in Xray.
I mean, I'll speak personally. I think it really depends on the use case. If you're trying to solve a particular problem, then that's going to affect what you're sampling and what you're honing in on. But again, I don't think I can really offer any kind of broad advice. The service is kind of configurable in terms of sampling, but it's really dependent on use case, unfortunately. Again, like Xray can be used in multiple different ways. You can really use it as a debug tool. You can use it as a general observability tool. You can use it in tandem to kind of build in architecture. So people use it in a lot of different ways. So again, it kind of depends on what you're actually trying to do.
Thank you, Tim. That really insightful. Awesome. So
Good
I guess
stuff.
it's my turn.
It's your turn, Tavi. Over to you.
So I hope you can share my screen. Let's say bye to Tim and Bob. So today I will be talking about large-scale serverless applications, because this is what we know the best. Quick intro to myself. I am admittedly the co-founder also of Dashbird. In Dashbird, what we do is monitoring serverless applications. But I've been a developer for over 14 years. I've worked on serverless applications for the past 5 years. worked on multiple companies that build large-scale serverless applications. And yeah, my experience early on with serverless was the thing that inspired me to actually start Dashbird. Today we will be covering kind of, first of all, just understanding the operational challenges for at-scale serverless environments. So if you have a really big deployment of something that's serverless, what are the challenges, and kind of if you're operating it in production day to day, you're running it, you have users on it, what you should be considering. A little bit about kind of the strategy around monitoring and operating it, and the effective solutions we have found for monitoring, security, and DevOps in production infrastructures. And the last bit is defending against known and unknown failures in those systems. So basically what we have found, the challenge being, is that at scale of like hundreds or thousands of resources, and by resources, we mean Lambda functions, but also databases, SQS queues, data processing pipelines, API gateways, S3 buckets. The complexity actually increases exponentially. And this is due to consider any type of a mesh of cloud resources communicating with each other. The problem is the amount of data, and also having the know-how of how your system can potentially fail. And in like a lot of those services, like your Lambda functions can have code errors, or they can timeout, but they can also run into concurrency limits, or they can run into timeouts, or there's SQS queues that can have really high delays, and like there's a large variety of things that can actually go wrong across all of your managed infrastructure. And the problem is, first of all, that there's just so much data that as an average user, it's really hard to kind of keep on top of all of that data being produced about your system. The other part of the problem is that while using those services, you need to really develop a deep know-how across your team and across all of the developers in your team to be aware of the fact that maybe API gateway can have a timeout, or an SQS queue can have too many items in the queue and it's not being processed, which leads to a higher delay in a data processing pipeline. And all of those little kind of potential unknown types of failures is really hard to look out for. So that's one of the challenges we see in some of the users of serverless, and especially at scale. So yeah, let's talk a little bit more about the variety of failures scenarios. So like if you're kind of reaching the stage where you actually have users in your system that are relying on your service, what we just suggest our customers do is look at every possible kind of part of your infrastructure, or part of what they are relying on as a possible point of failure that you should be looking at. You should be having some sort of a mechanism that tells you if it's not working. Yeah, there's a lot of timeout, like a lot of different examples here, from like code exceptions and things you can find in the logs to things you can find in the metrics. And there's like a kind of not an endless, but a large amount of things that as a company running anything in production at scale, you should be aware of. So, knowing all of this and kind of having that as a challenge, as a sidestep, I think it's a good way, or like a good point to think about the definition of observability just for a second, and then we can kind of see how it's relevant to this problem. So observability actually in Wikipedia is defined that it's basically a measure of how well you can understand the state of your system by looking at the outputs of it. So you cannot kind of, let's say you can't instrument your code, you cannot kind of SSH into it and look at what the memory is at any given point. So the having observability means that you can understand all of that, the entire state, by just looking at what it's producing, the logs, the metrics, the tracing data in Xray. So out of the box, if you have Xray enabled, you have CloudWatch logs, you have CloudWatch metrics, I would argue that your system is already, has observability. It's observable. You have the points of data that you need to actually understand what's going on. The challenge, however, is the large amount of data and the data being in silos. So you have metrics in one service, you have logs in another service, you have distributed tracing spans in Xray. And then as an engineer, or as even a product manager or an architect, it's really hard to navigate and understand that, but you do have that data. So, let's say we're a company that, is at this point where we're, have something already working. We need a monitoring strategy. We need to, get confidence in what we have in production at the moment, and also, gain the ability to kind of quickly react to anything that would possibly go wrong. So let's take a look at kind of the monitoring strategy, or kind of how you would approach it. Let's take a look at like mapping risks of the environment, and then as the last thing, coming up with requirements for the monitoring strategy. So if we look at so this slide, I would say maybe switched with the last one. To reiterate, observability comes across so many different services in AWS. So you have metrics, you have logs, you have Xray, you have access logs, you also have resource configurations, and you kind of, you have all of that data available to you already. So yeah, I think this is the right slide now. If we look at what you need from your monitoring and operation strategy, the most kind of high value items that we've seen in our customers and what we've experienced ourselves is the first thing by far in any kind of monitoring use case is reducing the mean time to discovery for especially customer affecting incidents, but actually anything that's an incident. So it's not that you need to learn the root cause immediately. What we see, the biggest factor of being able to quickly respond to anything that happens is how fast you learn about it, that something has happened, and it's kind of like in this part of your system, maybe a specific resource or something has happened. So the kind of, having alarms for everything that can go wrong, and then, that really reduces the time it takes to be aware of any problems. The other thing that kind of you achieve and should be the strategy is to gain confidence. So, if you are able to find out about things quickly, this increases your confidence to iterate, and it reduces the risk of if something goes wrong, like how long it takes to fix it. And the third goal is actually enabling developers to focus on the customer and not as much on actually keeping the application up and running, or dealing with the stuff, being worried about how the last deploy affected the functioning of the system. And as the last thing, we see that as you're learning quickly, you're detecting issues quickly on the fly. It enables you to quickly learn from mistakes and kind of evolve as a team and as a developer over time. So, all of that is great, but you cannot set alarms for everything, and you cannot kind of have this all magically solved at the snap of the finger. You need to start somewhere. And where we suggest, or how we work with some of the customers that come to us at this stage, is we start risk mapping. Basically, we see what are the business requirements for the system, like how fast do you need your APIs to have responses, what's the uptime percentage, what's the cost of your system. And the first thing we do in most of those cases, we set basic alarms and basic thresholds and SLAs and kind of indicators for the most kind of business focused requirements of the system. And if those don't fail, we're kind of happy, but we also go deeper. But this is kind of the first level of defense. The other thing we ask from the customer at that point is the kind of, what's the acceptable time to understand if something is not working? Like how deep do we need to go, or should we go with certain types of like detections, and like where's really the kind of ROI in looking at the compute data. And the third thing we make our customers kind of answer and kind of think about is, after discovery of the problem, how long is the acceptable time to actually fix it? So kind of, in short, what's the mean time to discovery that's acceptable, and what's the mean time to resolution that's acceptable? And we work, like, those are two really clear metrics that we work to kind of reduce and to kind of make the best out of. So, once we kind of have the goals and the strategy kind of understood, we're on the same page. We start thinking about the strategy for, like, what are the requirements for the monitoring kind of setup, or what do you need your engineers to have access to, and kind of what you need it to do. Where we usually arrive is three things that are the most important. These vary across companies, but like broadly speaking, these are the three main things. So the first one is basically navigating and interrogating really large amounts of monitoring data as quickly and as efficiently as possible. So as a developer, or if you're like running a serverless application, what we have found is that the first thing that it starts with is being able to actually understand what your system is doing at any point, and kind of ask it questions like, what's the failure rates, or what, like, did we have a request that asked for a specific user, or anything like that, and like how fast can you find out things about your system, and make that really easy. The other part is basically analyzing and detecting events that the programmer should know about, and kind of having an automated way of surfacing issues across the system. The third one is the capability to understand situations, and kind of the basically the mean time to resolution phase. So if you have a failure, what's the root cause, what happened, was there a deploy, who's affected, and kind of understanding that quickly and efficiently, and coming up with a solution. So those really are the requirements for most of the companies we work with. So let's take a look at those like parts individually. The first thing I would say is the most challenging, just because of the sheer amount of data and kind of the challenge, like the engineering challenge alone. In modern cloud environments, usually the data is in silos, so you have logs and metrics and traces. It's hard to kind of look and feel and see them. If you have like a lot of them and it's scattered around, then you have a lot of microservices, so it gets tricky. Also, we see that when it's cross-region, if it's cross multiple AWS accounts, it's also a bit difficult. So we try to solve that challenge. And looking at data from different angles, so you can have reports, dashboards, searches, and queries, and kind of bubble up or anomaly detection, where you see whatever that's kind of like not okay with your system, and kind of really interrogate that, and different levels of your application as well. So the account view, the microservice view, a single resource like a Lambda function and like how it's actually performing if there's any issues, and then down to one transaction level, which is similar to what we just saw in Xray, like the end-to-end trace and things like that. What we also kind of solve for our customers is the elasticity. So if you have, doesn't matter if you have 10 functions and that's it, then you have like 100 resources or like 40,000 resources and billions of invocations. We take care of scaling and making sure that monitoring data is continuously available. So quick examples here. If we look at account and microservice level views, the idea is to detect major problems and changes early on. We look at overall health, considering like the most kind of concerning areas, overall cost and activity metrics. So if there's anything crazy going on, you can see it here. You can also see the transactions or kind of the way resources are communicating with each other. Like, are your APIs, like how are your APIs talking with your Lambda functions and how the data flows, and if there's anything wrong with some of the resources. There's resource level views where we kind of help you understand the health and performance, the cost, and kind of identify problems at this stage when your like Lambda function might be broken in certain areas or certain times when it's being executed. Those include invocations, failures, cold starts, memory and cost and durations, anomalies in executions. Like, let's say that 100 of your invocations work fine, but then have twice the invocation time for some reason. So you would want to know about that. And yeah, all of the things you would kind of expect, like failures and ways to improve and align with best practices. And so here we arrive with the execution level. So in the execution level, we actually look at a lot of different things. This is an example of Xray that we also show in the view, but we also show the metadata of an execution, the events, the logs, the kind of surfacing of failures. We tie that into Xray segments, and we also link retries and kind of flag things like if it's a cold start or things like that. So you can actually have one view where you can see that, oh, this was an anomaly in some place, it was a failure, and also it was like a cold start as well. And here are the logs, here are the metrics, this was the event. Usually with that amount of data, you can immediately tell what's going on and if what the problem is. So given all of this, given that you kind of are dealing with situations where there's a lot of data, a lot of logs, a lot of metrics, what's really important for kind of being able to effectively understand the environments is searching, querying, and bubble up. So bubble up is what I just mentioned. We analyze all of the invocations that we see, and we bubble up the meaningful ones. So the ones with cold starts, the ones with like anomalies of any kind, failures. Then we give you the ability to query based on any type of imaginable like parameter, and we help you search for any free text, any user kind of ID or anything. So you can kind of connect logical kind of models or mind models into actual invocations. So I think this covers kind of the monitoring and kind of the way to look at operating serverless applications. Obviously, it's broad, but this is mainly how we think about it. The last part is about known and unknown failures. So in Dashbird, kind of one of the key features that we have, but also what we've seen resonating with like thousands of different users over the years is defending against fail states of the system. So if you have fails that you know about or you don't know about, how to find them, and we see the problem being twofold. First one is just understanding the potential failure scenarios. So how can they fail? Like how can different services fail? And usually this requires deep understanding of each and every service. And the other part that we see customers struggle with is if you even know about the things you should be monitoring for, how you should be managing the alert coverage. So if you have thousands of functions, how do you actually enforce those alarms across that surface area? So in Dashbird, what we do is twofold. First, we do failure detection from logs. We scan each one of the log lines that we ingest, and we group it together. We understand that, hey, here's a code exception, here's a timeout, here's some other service specific failure, and we understand when it started happening. Sometimes we understand the root cause, like if there's a downstream service failure or if it was a code change or whatever caused it. So we point that out, and we kind of make it really easy for you to find out that this happened and also to fix it. The other part that we do is with metric alarms. So if you have CloudWatch metrics, which you obviously do, we help you analyze large amounts of metric data on the fly, and we enforce our pre-built alarms, and we let you set your own alarms as well. So you can basically build your entire metric strategy into Dashbird, but a large part of it, while you onboard and while you kind of start first using it, is already there. So it's basically covering the different failure scenarios that can happen across your system. So the last bit that we do, and kind of where we have arrived as a product, but also what we see customers doing on their own as well, is continuous scanning of best practices, security threats, compliance failures, and those kinds of things. So for instance, in our platform, we have over 100 checks that we continuously run to detect waste, to detect security problems, bad posture, things like not logging out your API gateway requests, and we point those out, and we give you kind of explanations of why you should be looking at this or that, and kind of why we are checking this at all, and how to improve your system. So all in all, giving kind of, if you are going to approach the monitoring challenge at some point with serverless, like the last thing I would suggest is making a plan and practicing incidents. So if you have problems, or like, before you have actual problems, make a clear action plan and see if it works. Like test it in staging environments, train your team, document how it goes. If you have a real problem, definitely document it, make retros, and prevent stuff from happening twice, and track against actual performance and goals and like SLAs. So see what the reality is compared to the goals and the SLAs of what you hoped it would be. And it takes a lot of time and effort. There's a lot of great materials online, especially the Well-Architected Serverless white paper and the Well-Architected Framework white paper. We've also gotten a lot of help from the AWS solutions architects and the serverless community. And we've played around a lot with third-party tools as well. So there's a lot of cool kind of different materials out there that you should kind of dive deep into if you're in that phase of your serverless journey. So this is the end of my presentation. And also this concludes the webinar. So thank you so much, everyone, for attending, and hope you enjoyed it as much as I did. And see you next time. Thank you.